Okay, fine. Sure. So we'll just continue. Okay, we will continue from where we left actually. So what was the last thing that we were discussing? The last thing that like we were discussing is we just learned about how this tracing happens, everything, right? So there was one common question, like it was, like every time that I hear is you just keep on executing. How you're just continuing from third after third, stopping at third line, then how you're continuing from fourth line is the question. Very simple. See, already you know very well that like first line there is some execution is happening. Second line there is a function call, and then after, so okay, second line also some line of code is there. Third line also some line of code is there. Fourth line some function call is available, and fifth line again a normal some line of code. Sixth line also normal line of code is there. How will you execute this? First line you will execute, second line you will execute, third line you will execute, fourth line when you see a function call, automatically you will go to the definition of the function, you will execute everything. Once the function is over, what you will do again, you have to return back where you stopped. You stopped somewhere, you stopped at line number 4 and you went somewhere and you're doing some other process. When that process is over, you need to again return back to the same place and you need to continue from there for 5 6 7, and you have to keep moving. That's what the usual thing, right? Same is what we are doing here. I'm executing first line, second line. While I'm just executing third line, I'm just stopping. And there is a function call, so I'm going somewhere to the function. And once that function is over, I'm just again coming back here. When I'm coming back, where I need to continue on. Up to third line I have done. I have to continue from fourth line, right? So that is what for every activation area that we were doing. Every activation area was stopping at line number 3. Once if the process is over and I'm again returning, coming back to the third line, I need to again continue from fourth line. That should be the procedure, right? Okay, so I think we are stopping at line number 3. When we are again coming back to that line number 3, we need to continue from line number 4. That's a normal, like control flow that would be happening. Now the thing is, we were able to see two process over here. One was creation of activation area. The other one was deletion of activation area. These were the two different things that I am able to see. And the process of, like creating activation area, right? That phase, we call it as ascending phase, or otherwise we call it as calling phase. Okay, what we call it as? We call it as ascending, or otherwise we call it as calling phase. Okay, ascending or otherwise calling phase, we call it as. This is one thing. And what about the deletion of activation record? Deletion of activation record can be also called as descending phase. It has to be called as descending phase, or otherwise it will be called as returning phase. So it is also called as descending phase, as well as it is called as returning phase, or otherwise this is what we call it as backtracking phase also. Okay, so what we are doing, we are traveling in some path, and once we travel in some path, after some time we are traveling back in the same path. So we are traveling forward and backward, and this backward movement is descending phase. Backward movement is what we are also calling it as backtracking phase. That's why before backtracking, I just directly came here to this recursion, because recursion is only capable of exhibiting this backtracking property actually. Okay, so first thing is we need to understand what is ascending phase, what is descending phase. And one more thing that you need to observe is all the lines that comes above the recursive call, they were all executed in the ascending phase. That is during creation of activation record. And all the lines of code that comes after the recursive call, they were executed in the descending phase. That is in the backtracking phase or deletion phase. So something you want to do, something that you want to execute in the backtracking phase, you need to write those lines of code, those piece of logic after the recursive call. Suppose if you write it after the recursive call, they will be executed in the returning phase, backtracking phase. Okay, so all the lines of code that comes above the recursive call will be executed in ascending phase. All the lines of code, piece of lines of code which is coming after the recursive call will be executed in the descending phase. So first you need to understand what is ascending phase, what is descending phase, and you should know which line of code will be coming under ascending phase, which line of code will be coming under descending phase. So all the lines of code which comes, including the recursive function and the lines of code coming above it, will be included in the ascending phase. That will happen in the ascending phase. All the lines of code that comes after the recursive call will be executed in the descending phase. Okay, is that point is clear for everybody about what is ascending phase, what is descending phase, what are all the lines of code that will be executed in the ascending phase, what are all the lines of code that will be executed in the descending phase? Is it everybody clear with those? Okay, in descending phase, what lines will be executed, right? So in the descending phase, if you see this line, like for example, here the recursive call is in third line, right? All the lines of code that comes after, which is fourth line. So second line will be executed in the ascending phase, fourth line will be executed in the descending phase. You could have noticed it. This printf statement is 3 to 1 printed, which was executed when I was just creating activation. And this fourth line is just what this 1 to 3 got printed, and that was executed from top to bottom, which is deletion. So backtracking phase, okay, returning phase, fourth line could have executed, and the moving forward phase, that is ascending phase, second line could have executed. So all the lines that comes above the recursive call will be executed in the ascending phase. All the lines of code, piece of code that comes after recursive call, it will be completely executed in the descending phase. So is that clear, students? Is that clear? Okay, thank you. Fine. So now the next stuff that we will get into is, let me give you one example, and I think hope you people can try it out. Okay, so let me give one example code, piece of code. Okay, so I'll just take only one recursive call, integer return. Okay, I'll just take void return type. func is a function and parameter is n. And what I do is, inside this, let me go with checking if n greater than 0, and if n is greater than 0, let me go with first of all printing, okay, printf percentage d space comma n minus 1. I'm just going to print, and after this I'm just going to go with func of n minus 2 and then semicolon. It is going to be func of n minus 1. Sorry, we'll go with like this, printf, okay, percentage d space comma n n I will be printing, and the next one more printf that I'm going to place, which is going to be printf percentage d space comma n my n divided by 2. So now the question is, if for this particular, like a recursive code, if n value from the main function, if n value was provided as 9, what will be the final output? Can you form a same main memory and creation of activation area, all the process, same process from main function, the value function C was called and the value was 9. Okay, so just tell me what is going to be the final output over here. So for this, trace the one and just post it in the chat box quickly, please. Just 3 minutes. Just take 3 minutes time. I'll be also, not speaking for 3 minutes. Don't think that I'm not audible. So everybody just work on it and everybody post your answer in the chat. Students, I just see few answers only. Just kindly everybody, post your answers in the chat box, please. I can, so that I can just check what is the level of understanding or whether I need to repeat or not repeat. I have to decide. Okay, fine. So I just have received many answers from you. Let us just discuss, like which answer is right and which is not, which is, like, okay, fine. So yes, we'll just quickly trace it out and we'll just find whether the answer is right or not right. Okay, we'll just check it out. Okay, fine. So what is the procedure first thing? We'll just go a little quickly because already we have seen this, right? So we will just create a stack memory. Let us consider this to be stack memory. First, we will be creating an activation area, and this activation area is for func, which is going to accept 9 as a parameter, initial parameter value. So I will come inside, I will take a variable with variable name n, and the value is going to be equal to 9. And I just coming inside, let me consider this to be line number 1, line number 2, line number 3, line number 4, line number 5. So now I will just start with line number 1. What is line number 1? Checking whether the present n value is greater than 0. Yes, it is greater than 0. Okay, yes, it is greater than 0. So condition true, I enter into second line. Second line, what we need to do, we need to start with printing n minus 1, which is 9 minus 1, 8 we will start with. Then third line, we have a function call. So third line function call means one more activation area will be created. And this is going to be n minus 2. So it will be func of 7. 9 minus 2, 7 it will be. So memory block will be created with value 7. Variable name is n. And we will start with the first line, which is checking whether the present n value is greater than 0. So yes, present n value is greater than 0. So I need to next move to second line. Okay. So second line is printing the present value of n minus 1. Okay. Printing the present value of n minus 1. So 7 minus 1 is 6. So next value that we have printed is 6. And next again coming to third line, again there is a function call. So one more activation area we need to create, where a memory block we will be creating with value 7 minus 2, 5. Variable name is n. And this is going to be func of 5. And the value is going to be the number of line, the line that we are going to start with is first line. Present n value greater than 0. Yes, 5 is greater than 0. Enter into second line. Printing n minus 1, which is 5 minus 1, 4 we will be printing. And after that, third line is again a function call. So one more activation area I will be creating, and a memory block I will be creating. 5 minus 2, 3 will be the value. Variable name is n. Again, let me start it from first line, which is checking whether the present n value is greater than 0. Yes, the present n value is greater than 0. So condition true. So I enter into if block, where I'll just start with second line. What is second line? Printing the present value of n minus 1. So which is 3 minus 1, 2. I will be going with n minus 1, 2. Then I need to come to third line, where what is third line? Third line is function call. Function call is func of n minus 2. So one more activation record. So look here, this is going to be func of 3. This is, and here it is going to be func of 1. 3 minus 2 is equal to 1. So we are going to create a memory block with value equal to 1. Variable name is n. And line number 1 we will start with. Line number 1 is checking whether n is greater than 0. Yes, condition true. So I'll enter. I'll go with line number 2, where I will be printing n minus 1, which is 1 minus 1 is equal to 0. And then coming again to third line, it is a function call. So one more activation area, which is going to be func of minus 1. Because 1 minus 2, right? Minus 1. So I'll start with first line. So here a memory block will be created with value minus 1. Variable name is n. So condition is false. Okay, so when condition is false, I will come out of if block. I'll execute the close curly braces of the function. So automatically this topmost activation area will be deleted, and I will enter into the next activation record. And coming to the next activation area, the last line that executed is line number 3. So I need to continue from there. So fourth line I will start, which is printing the present value of n, which is 1. So 1 will be printed. What is the next printf statement? Next printf statement is n divided by 2, which is 1 divided by 2 will be equal to 0. So next 0 will be printed. Next, after that fifth line is executed automatically. Okay, we have executed fourth line as well as fifth line. So after fifth line is executed, we will come out of if block and we will see the close curly braces. So this topmost activation area also will be okay. It is also will be seen. Okay. Now coming to the next activation record, it was just executed up to third line. And now again, we'll continue from fourth line, where fourth line is printing the present value of n, which is 3. And next one is we need to also print n divided by 2, which is 3 divided by 2. 1 we will be printing. And after fifth line is executed. So here also fifth line is executed. Then After fifth line is executed, we'll come out of if block and we will execute the close curly braces, and this present activation area will be deleted as well. Okay, then we will enter into the next immediate activation record, where we have to continue from line number 4. So fourth line is printing the present value of n, which is 5. So we will print 5, and the next one is fifth line. Fifth line is printing n divided by 2, which is 5 divided by 2 is equal to 2. So after fifth line is executed, then we will come out, close curly braces will be executed. So this current activation area have to be deleted completely. And after this, we need to come to the next activation area, fourth line. Fourth line is printing the present value of n, which is 7. And next to fifth line is 7 divided by 2, 3 should be printed. Yes. So after 3 will be printed, then this activation area also will be deleted, because after fifth line we have to come out of if block and close curly braces of the function needs to be executed. Then final activation area, we need to print a fourth line, which is n, which is 9 I will be printing, and the next one is fifth line, which is 9 divided by 2, 4 will be printed. So the output is final. See, after fifth line is executed, this activation area also will be deleted, and this entire stack memory after it becomes empty. Now, when you just look at this complete array, 8642, okay, 86420103152739 is the answer. 86420103152739 is the answer actually. Okay. Just have a look at what is the answer that you're posting. 86420103152739. People, you have answered this. Super. That you have got to understand the complete procedure very clearly. So any question. Okay, I think hope everybody know there is a separate section called as automata fix, where in automata fixes, like understanding the code is very important. So if any recursive based code is given, I think when you look at the code, you will easily understand the logic. Okay, what they have done, what could be the output, what could be the mistake that has happened. So when the output is given and some mistake is provided in the recursion, now you will be able to easily figure it out, because you know the original process. You know the original process, what have to be done. So now it will be very easy for you to, like first of all, trace any given recursive code. So will everybody be capable of, in any recursive code is given, will you be able to trace it now? Do you clearly understood what is the procedure? Will you be able to trace it out now? Okay, fine. Fine. So I think now the next thing that we should be concentrating over here in recursion is, okay. So the next thing that I need to be, we need to be, like going through is about. I think now coming here, I think we just started with the types of recursion, right? I think actually we just started with head recursion, then via like tail recursion, tree recursion, nested. So now whatever the like the sample code, whatever we have taken, actually I would say what is head recursion is the first line of the function have to be the recursive call. The first logical line have to be the recursive call. Same example, if second line, this line is not there, means this is head recursion. Because the first logical line, apart from base condition, the first logical line is a recursive call. So if the head of the function, starting of the function, if the head of the function has a recursive call, then it is called as head recursion. Okay, suppose same thing, like the contrast part is, if the list, this line is not, fourth line is not available, and if the last line, if the tail of the function, tail means end, if the end of the function we have a function called, last line of the function we have a function call, then we call it as tail recursion. What I have done is I have shown you a hybrid version in the sense I combined both these things together. I combined head and tail together, and I've shown you what is the behavior of head and tail. In head recursion, what would be the behavior? First recursive call, all the lines of code coming after the recursive call means everything will be executed in the descending phase. So using head recursion, we could understand the importance of descending phase. Tail recursion is all the logical line will be coming, last only recursive call will be there. So all the codes which is coming above the recursive call, they will be all executed in the ascending phase. That is the primary motive of the both the type. But I've combined both these things, and in the same example, I showed you what is ascending phase, what is descending phase. Both the things I showed you, both the behavior of head recursion, behavior of tail recursion, both I have shown you already. And what about the next one, tree recursion? But before coming to tree recursion, time is one of a very important aspect. Time and memory is one of a very important aspect of any code that we do. See, whatever like solution that we are giving, we mention a word oftenly called as efficiency. How efficiency of a code is defined? What are all the factors that impact the that create impact on the like efficiency of a code that we are writing? Three important factors: time, memory, and the source limit, the number of lines of code. So first, two primary factor is time and memory. The third criteria is the number of lines that we code and the readability of the program counts. But the first two efficiency lies on the time, and major efficiency lies on the like time and memory. So coming to time, when a recursive code is taken, how will I find what is the time that this particular recursive code will be taking? When speaking about time complexity, I just have to mention about two things. There are two different ways of finding time complexity. One thing is, for a certain input, we have to say like 2 seconds of time, 1 second of time means, so very perfect, like exact time, if you're saying, that's one category. The other category is just generalization. We will be giving a growth function. This growth function will determine what is the rate in change of time taken by the program when there is a change in the input. Okay, so what will be the change in rate and change in? So what is the relationship between the time and the input when the input is changing? When there is a change in input, what will be the relationship between the change in input as well as the change in time taken by the program? So for like for determining the relationship between both of them, we define something called as growth function. In mathematics, we call it as polynomial function. Using a certain polynomial function, we make a relationship, we create a relationship, or we define the relationship between a like the change in input as well as the change in time taken by the program. Okay, so for example, I will just list out all the like the most frequently used time complexity equations I will take. First equation, let me take f of n is equal to 1. F of n is equal to 1 is a very basic like function. Then f of n is equal to log base 2. Okay, f of n is equal to log base 2 of n. This is one common function, then f of n is equal to n is a common function. Then the next thing is f of n is equal to n log n multiplied by log base 2 of n. This is next commonly used stuff. Then f of n is equal to n square is common thing, and f of n is equal to 2 power n. These 6 equations are very commonly used equation, in fact. And we need to take this equation and we need to understand how a problem will come under this each and every category of time complexity. We need to understand that. Okay, see, listen carefully. Any program that you take, the program will definitely, it will be taking a certain input. Am I right? Definitely every program will take input and some processing will happen. After processing, a certain output will be thrown. This is applicable for any mathematical as well as programmatical problem. When you take a program or problem or a solution, input will be provided to the solution. A certain process will be happening, and after the process is over, a certain output we will be getting. Now the question is, when a certain input is given, the process we have done saying, right, we have something called as iteration. How many, like looping iteration will be happening. So we need to check the time taken by that particular procedure we have implemented. So when the input changes, the time taken by the program, it will change, might change or might not also change. But we have the possibility of when the input of the program changes and the time taken by the program also, solution also will be changing. Okay, so keeping that in mind, we are now taking all this equation to represent if there is a change in input, what will be the change in time taken by that. So here it is input and time. So we need to find what is the relationship between both. So whatever is the relationship we are getting, it will be formed as an equation, right? A polynomial equation will be coming. So we are defining the, like the growth. Okay, when the input is growing, how the time is growing. So we are taking the growth rate and we are determining it with the help of a mathematical equation, like one of the top 6 mainly used equation I have taken already. Okay, so now for whatever program that we have taken, basically we will just check which like time complexity will fit best. But we will take each and everything and we will first of all understand for what kind of behavior, what kind of solution it will be fitting. First of all, let me take f of n is equal to 1. Can somebody tell me if f of n is equal to 1, what this is trying to describe? Where n is the input, n is the input, and f of n in the sense f is the function, okay, for which we need to find the time taken, and right side is the time equation. This is time equation and this is the input we have. So by using this equation, what you can just observe from this, what kind of program or what kind of process can come under this f of n is equal to 1? What is that you observe from this equation? Can you just post all your opinion on what is the equation is all about? What is that you're observing from this equation? Yes. Yes, graph parallel to x-axis, constant time. Constant time, best runtime. Time is constant. When input changes, the time taken by the program will not change. Yes, exactly. Okay, what usually a lot of people thinks that, okay, a lot of people thinks that f of n equal to 1 means what this describes is only one iteration will be happening, only one process will be happening. That's where we have to say it is 1, f of n equal to 1. No, it's not like that. You see, you can rewrite this equation as f of n is equal to 1 multiplied by n power 0. Can I write like this? 1 multiplied by n power 0, or otherwise directly f of n is equal to n power 0, because anything power 0 is going to be 1 ultimately. So what happens is, here in the function, you give n is equal to 100, you give n is equal to 1000, you give n is equal to 10 power 5, you give n is equal to 10 power 12. Whatever is your n value, let it be. But whatever is your n value, if you take it and if you just give n power 0, 100 power 0, 1000 power 0, 10 power 5 power 0, 10 power 12 power 0, definitely you will be getting 1, which means whatever is your input is, let your input change whatever like to whatever value, whatever extent, but the time equation, you look at the time taken is not changing, it keeps on 1. So what I can say is, like for solutions, for codes that we are writing, where whatever input changes, If the time taken by the program does not change with respect to any input change, then those kind of program we can call it to be like constant time taking solution, and we can take that and we can represent it with the help of this particular equation, which is 1. And there are 3 asymptotic notation is available. There are 3 asymptotic notation is available. I'll make it very short about this asymptotic notation. This asymptotic notation, one is big O, and the next one is omega, and the next one is theta. Okay. Can somebody tell me if you already know what a big O says and what is omega is saying and what is theta is going to say? Can somebody tell me what is this? All these 3 things is going to state first of all. What is big O? What is omega? What is theta? Anybody with what is for big O, omega, and then theta? See, usually what big O defines is, big O defines, like big O will say your worst case. That is, what is the maximum time that particular, program can take? The maximum time, worst case. In the worst case, what will be the time? Maximum time that it will not exceed this time. Definitely, for sure, it will not exceed this time. So that is what using big O we will be implementing. So if there is any solution where it is going to take constant time, we will represent, okay, big O of 1. Even for any input, if you take, it is definitely, it will be taking constant time. The time will not change. So big O of 1, I can say, where big O of 1 means worst case, maximum time that can be taken by the program. And what next one is omega. What is that with omega? Can you just tell me omega, what omega defines? What omega is defining? Omega will define the best case. So best case in the sense, what will be the minimum time? Okay, what is the minimum? See, for example, we'll take an array. In array, if I want to delete an element, I could delete the last element, I could delete some middle element, and I can also delete the 0th index element. Now tell me, if I want to delete the last index element, what is the process that we will do? Just simply I will do one thing, where I will be decrementing the size of the entire array. I will be decrementing the size of the entire array by 1. I'll be subtracting the size of the entire array by 1. That is only one process I will do. So any test case, any array, let it be given. But if you want to delete the last index element, only one set of process you will do. So which means constant time will be taken only if you want to delete your last element. Same thing, if I want to delete 0th index element, what will happen? If I want to delete 0th index element, all the element coming right side to that, they have to be left shifted by 1. And finally, the array size also have to be decremented by 1, for which we will have to iterate for n times. Like whatever is the size of the array is, that many times I need to do left shift process. That is worst case. So I have to say big O of n. In worst case, it will be taking, this is the time complexity. For best case, it will be taking this. What is the minimum time? What is the maximum time? What could be the average time? 3 aspects is there. For any program you take, what is the maximum time this can take? What would be the minimum time it will be taking? And what is going to be the average? So best case, worst case, average. So big O will be defining a worst case, where omega will be defining the best case. That is the minimum time taken. So for the same array, what you will do, array, for deleting array element, worst case I will say big O of n, and best case I will say it is going to be omega of 1, I will say. Okay, so it is going to be best case. What about theta? Theta we will define average case. Okay, we will be defining the average case here in theta. So average case in the sense, any input if you choose, what will be the average value? For example, if you take an element, you take array of 5 elements. Okay, if you want to remove if you want to remove the fifth element, you will take only one constant time. That's why I've said best case it is omega of 1. Suppose if I want to delete the first element, then all the elements coming after that should be left shifted by 1. So that's why I'm taking big O of n. Now, what is the average cases? If the first index element have to be eliminated, how many processes we will do? See, last element have to be inserted means only one process. 4 means one left shift and one decrement of your n value. So 2 set of process. 3 means 2 left shift we will be doing, and 1 decrement of array size will be there, then 3. For 2, it will be 4, and for 1, it will be 5. So if I take 5 different, if I want to delete fifth element, I will take only one process, one iteration. Fourth element, 2 iteration. Third element, then 3 iteration. Second element, 4 iteration. One element, 5 iteration. So I will just take this everything, and if I want to know the average case, I will add all this iteration together, and I will divide it by 5, because totally I took the 5 different possible input, and for all the 5 different possible input, if I need to get the average case, I add all the iteration divided by 5. So what it is looking like actually, it is looking like sum of the first n natural numbers divided by n. So sum of first n natural number, there is a formula n multiplied by n plus 1 divided by 2. So if 5 multiplied by 6, 30, 30 divided by 2 will be equal to 15. Yes, 15 is the sum of all these elements. But what happens is whole divided by n is also coming, because we are dividing it by 5, the total number of possibilities, so that we get the average case. How we can rewrite this into? We can rewrite this into n multiplied by n plus 1, the whole divided by 2n, we can take it as. Okay, so I think we can just simply divide this n and n, cancel out, and the remaining term will be n plus 1 the whole divided by 2. Coming to n plus 1 whole divided by 2, we can write this as n divided by 2 plus 1 divided by 2, where 1 divided by 2 is a constant term. We should always ignore the constant term. And according to n divided by 2, n divided by 2 is actually, like it is a linear equation. So where this divided by 2 also constant also, I will ignore. I will take only that n in only. So I would say that in average case, or what it will be, average case also, it will be equal to n. So theta of n is the average case. So any solution if you take, we will have worst case time complexity, we will have best case time complexity, we will have average case. Certain problems, all the three things will not change. For certain problems, they will change. That's a issue. That's a question. Say for certain problems, worst case, average case, best case will be different. For certain problems, if you see worst case, best case, average case, everything will be same. Depends on the concept, depends on the question. But you need to understand all these three asymptotic notation, where one notation, like big O defines the maximum time that can be taken by the program, where omega defines the minimum time that will be taken by the program, where theta defines the average time that will be taken by the program. Okay, we need to also understand that. So we could say that if f of n equal to 1, what this function describes is, this describes that whatever change happens to the input, the time will never change. So that kind of solution, I can bring it to big O of 1. Now, what is the next equation? So first of all, let me just go ahead and I'll just put forth. Is it everything is clear up to what we have seen now? Any clarification, post in the chat box? 2 minutes, 2 to 3 minutes I will give you. Any clarification so far? Post it in your chat box. I'll clarify your doubt. Then we will move. I don't want to go very fast. We have enough time. Let us, go slowly, and we will keep everything, to the depth. Whatever things that we are learning, whether the basic thing or a complex thing, let us, get the fullest of it. Okay. So post your, clarification if you have anything. 2 minutes. I'll wait. I'll not be speaking. Don't think that my voice is audible. I'm not going to. I'm going to keep mum. So 2 to 3 minutes. It's to you. You can post your clarification. I can clarify whatever we have seen so far, whatever things, not only this one, asymptotic notation or things, whatever we have come before that, everything is just, you can put forth your question, please. Okay. Can you please explain average case again? Okay, I'll just explain you the average case again. So coming to average case, if we see, listen carefully. I take an array of size 1, 2, 3, 4, 5, 6, 7. I will take index 0, 1, 2, 3, 4, 5, then 6. Just 1 minute. Just 1 minute. Okay. So coming here, I have taken an array of size 7. Let me pick few random elements inside it like 10, 5, 20, 11, 6, 4, and then 12. We have taken 7 elements. Now we want to just delete. Okay. Delete an element. For deleting an element from the array, what is the process we will do? Suppose if I want to delete 6, what I will do? If I want to delete 6, I will take 4, I will left shift it by 1. I'll take 12, I will left shift it by 1. And then I will reduce the size of the entire array by 1. This is a process. So did everybody know how to delete a particular element from array? Usually, normal way of deleting. Not using inbuilt function of Python and deleting. You know the logical process of how an element will be deleted from a particular, memory block. It cannot completely be destroyed until it is inside stack memory. Okay. Okay, fine. So I think now coming here, so for any element I need to delete, whatever element coming after that, they should be left shifted by 1. So one left shift means taking one element from one index and placing it in previous index, which will take 1 unit of time. One process, 1 unit of time. Okay. Now the question is, what is the best time? What is the minimum time? And what is the maximum time? What is the average time? So what will be the minimum time is, if I want to delete the last index element, I don't want to do any left shift process because after that, there is no element is available. So only thing that I need to do is, I need to just simply reduce the size of the array by 1. That is the only one process I need to do, which I say is constant. Any input you take 1,000 elements, you take 10,000 elements, you take 1 lakh elements, whatever is the number of input might be. If you want to delete the last index element, you will take only 1 unit of time, which is something constant. It's not like 1 unit of time. That's why I'm saying constant time. Same thing, that's not changing. Let it be the number of elements be 10 power 12 elements, 10 power 5 element, whatever it is. But if you have a scenario of deleting your last index element, you will just go through only 1 unit of time, which is constant for all the test cases. So I would say the minimum time that will be taken for deleting the element here would be, minimum time means omega. So I will be going with minimum omega of 1. Then what is the maximum time that will be taken here? Maximum time means if I delete 0th index element, I will get a maximum time. So suppose if I want to delete 0th index element, what I will be doing? First, I will take 1th index element, I will place it in 0th index, 1 iteration, which is 1 unit of time. Then I need to take 2nd index value, place it in 1th index, 2nd operation. Then 3rd index value to 2nd index, 3rd operation. Then 4th index to 3rd index, 4th operation. Then 5th index to 4th index, it is 5th operation. Then 6th to 5th index, it is operation number 6. And what is the next one more thing? I need to reduce the array size by 1. That will take 1 extra time, which is going to be 6 plus 1, 7. So totally how many processes happening? 7 processes happening if you want to delete 0th index. Suppose here there is totally 7 element is available. That's why 7 operation took place. Suppose if you take an array of size 100, how many processes could have happened? 100 operations could have taken place. 1,000 processes could have taken. 10 power 5, 10 power 5 operations could have taken place. So what we can call this to be? We can call this to be linear. When there is a increment in the time, there is a linear increment in the time taken also, the number of iteration also. So this will come under order of n, big O of n, because it is maximum time. So we go with big O. Now, what about the average case? Average case means you take the all possible input, you just take the number of iteration. For 0th index, how many number of iteration? Only 1 iteration. Sorry. For deleting the element in 12th index, last index, how many iteration? Only 1 iteration will be taken. Because only if it is last index element means only I need to reduce the size of the array by 1. So only 1 iteration. Suppose if I want to delete 5th index element, last 2nd index element, I need to do only 1 left shift and 1 decrement of array size. So 2 iteration. Okay, 1 plus 2. Now, next, if I want to delete this 4th index element, 3 iteration will be taking place. So 5 to 4, 1 iteration, 6 to 5, 1 iteration, and reducing the size of the array by 1, that will take one more element. So 3 iteration. So element at 3rd index, it will take 4 iteration. Element at 2nd index, it will take 5 iteration. Element at 1th index, it will take 6 iteration. Element at 0th index, it will take 7 iteration. So I have taken all different possible input, all the index I have taken as input, and I have just also took the number of iteration that it will be taking. I have added all the things. Suppose if I want to know the average means how many different possibility you took, 7 different possibilities. So divide the entire thing by 7, you will get the average. That's what usual average means, right? If you add 7 items, then you have to divide it by 7 so as to get 7, average. Same thing we are doing. I took every possibility I added and I took 7 different possibilities. So I'm dividing it by 7 to get average. So this is looking like sum of first n natural number, like 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to 7. How many total number of element is available? Up to that, we are just summing all the elements right from 1 to n. So if we have to add all the numbers right from 1 to n, we have a formula which is n multiplied by n plus 1 divided by 2 is the formula for sum of first n natural number. Then the whole thing have to be divided by 7, which is the number of elements provided in the array. So when you have something like x divided by y, the whole divided by a means you can write it like x divided by y multiplied by 1 divided by a. You can take this a as a reciprocal and you can multiply. Same thing, you can take this division by n and you can do it as a reciprocal where multiplied by 1 divided by n, so that it becomes, like this denominator n and this numerator n both cancel each other, and the remaining part that we will have is n plus 1 divided by 2. Whenever you are deriving a time complexity equation, whatever the constant terms that you're having, you need to ignore those constant terms in terms of time complexity always. So I can take this n plus 1 divided by 2 as n divided by 2 plus 1 divided by 2. So taking n plus divided by 2, 1 divided by 2, I think this plus 1 divided by 2 is completely a constant, so we ignore it. And taking this n divided by 2, this division by 2, this value 2 is also a constant, so I ignore it completely. And the remaining term that I have is polynomial variable n I have. So I can say that this can best fit into the equation f of n is equal to n. So the average case, which is theta, can be taken as n. So theta of n will be the test case, average case analysis. So this is average case analysis, which is theta of n is the time complexity. So this is the minimum, maximum, and average case analysis. Okay, I think this could have been clarified now. Yes, anything else? If you want to go ahead, you can also ask me, please. Next. Okay, I will show you how to calculate time complexity. Next thing that we will be looking into that only. I'll tell you how to calculate time complexity for a particular simple, like recursive program we took, right? How will we find the time complexity? We will take few, like lot of examples and we will do it. Okay, can you give an example to calculate the time? Yes, we will definitely do it. Anything else apart from the teach the average case once again? Yes, I have done it. Best case also I have done it. Worst case also I have done it. Does while loop uses, it is not, see, big O notation does not depends on whether while loop, for loop, or recursion we are using. Big O notation will define what is the maximum time taken by the something. See, if you take quick sort, people says that quick sort in best case it will be n log n, but in worst case it will be n. So you have to say big O of n, but you can say omega of logarithm of n. It depends. And when you see, okay, so the next one, tell worst case, best case, average case. I have explained one example. What is the difference between recursion and backtracking? See, the recursion and backtracking should not be compared. Recursion is a technique using which backtracking is done. That's it. Recursion is a technique using which we are doing backtracking itself. So it's nothing like, like backtracking, difference between recursion and backtracking. Both are just codependent concepts. Using recursion only, we are performing backtracking itself. Without recursion, there is no backtracking. Yes. For every program, we used to mention best case as omega and worst case as big O. Yes. Yes, it is always good to represent, like big O notation, because when you know the maximum time only, you can know, okay, what is the level of the program. See, if you just keep only use this minimum notation, means people does not know what is the maximum extent of time that it can be taking. So always prefer to go with big O notation. Always represent big O notation first. You should know what is all the three things: minimum, maximum, average. But you can give more importance to maximum time complexity, which is big O notation. You can give more concept, more importance to. Yes, every method, if you take best to worst average case will be there, but depends whether all the three things are going to be like same or difference is the matter. But for everything, you can represent the three different notation. No, see, for tree recursion, the time complexity will be differently calculated. For head and tail recursion, the like time complexity will be calculated in a very different way. Okay, let us now speak about how time complexity can be calculated for the like the recursive code that we have already taken. For the recursive code which we have already taken, I will just explain you that how we are going to find the time complexity of this given code. Let me copy that code first of all. Okay, so let me just copy that entire code. Okay, I think now I have taken this program, right? Okay, now remember something. Every single process you will be taking 1 unit of time. Every single operation will be taking 1 unit of time. Now what I assume is, see, I think I don't know how many person know, how many of you know recurrence relation in mathematics. Do you know recurrence relation in mathematics? Recurrence relation concept in mathematics. Okay. So, do anybody have knowledge of what is recurrence relation? Have you worked on recurrence relations? No. So, using the recurrence relation mathematical concept only, we are going to find the time complexity. I'll just explain you. I'll just do explain you. Now, coming here to this particular code, first of all, we need to form a recurrence relation. I'll tell you how to form. If this entire function, let us assume that this entire function is going to take some t of n unit of time, it will be taking entire function together, all together. Now I will just go line by line. For every line, I will just check what is going to be the time. Then I can take the sum of all the four line time taken, right? I can add all of them together, and I can just say all of them when it is added together, it is equal to t of n unit of time. I'm just assuming that the entire function will take t of n unit of time. Now coming inside, for checking whether n is greater than or greater than 0, it will take 1 unit of time. For just simply checking n greater than 0, it will be taking 1 unit of time. And for just simply printing a value, it will be taking, it's a single operation, it will be taking 1 unit of time. Okay, it will be taking 1 unit of time. And coming to this fourth line, how much time it will be taking? It will be taking 1 unit of time. And then coming to this fourth line, okay, coming to this third line, if func of n is taking t of n unit of time, then func of n minus 1, how much unit of time this will be taking? Can you people tell me how much unit of time the third line will be taking? Okay, fine. See, I'll just tell you that if FUNC of n is going to take n t of n unit of time, then FUNC of n minus 1 will be taking t of n minus 1 unit of time. It will be taking t of n minus 1 unit of time. Okay. So see, if a same function, if it is taking n as a parameter, if it is taking t of n unit of time, then the same function, if it is taking n minus 1 as a parameter, it should be taking t of n minus 1 unit of time, right? So now I could take this and I could completely write it as a recurrence relation. I'll tell you how we are going to write it. So now if you take this first line time complexity, second line, third line, fourth line, if you add all these things together, it will be equal to t of n. Am I right? Because the overall function take t of n unit of time, then all this individual line time, if you take an add, it will be equal to t of n. So I can write t of n is equal to how much one unit is there? 3 1 unit separately, so it is going to be 3 unit, and t of n minus 1 will be coming. So we need to take t of n minus 1 plus 3 unit of time I will be taking. And if this is if n is greater than 0. There is also one more condition is there. Suppose if n is equal to 0, what will happen? N is equal to 0 means this condition will be checked. For checking this condition, 1 unit of time will be taken, but this condition will be false. If it is false, we will not enter into these 3 lines. These 3 lines will not be executed. I'll come out of if block and it will over. So which means only 1 unit of time will be taken if n is equal to 0. So t of n is equal to, okay, t of n is equal to 1. Okay, if t of n is equal to 1, if n is equal to 0. Okay. So if t of n is equal to 1, if n is equal to 0, this is one thing. So t of n is equal to t of n minus 1 plus 3, and then t of n is equal to 1 if n is equal to 0. Okay, if n is equal to 0. Okay, so this is a recurrence relation we have taken, right? This recurrence relation have to be solved with the help of one technique, one method called as successive substitution technique. There is a lot of different way, but this is a very easy way, successive substitution technique. Okay, so coming to successive substitution, first of all, I will take the very first equation, which is t of n. T of n is equal to t of n minus 1 plus 1 I will take. Whenever we have a constant term, we will change that constant term to 1. So 3 is a constant. So when you have a constant, you take 1 instead of that. So this is the first equation that I will be taking. So let me consider this to be equation number 1. Now, what we need to do is, on the right side, we are having t of n minus 1, right? Let us try to find the value of the t of n minus 1. So t of n is equal to t of n minus 1 plus 1. What will be t of n minus 1 value will be equal to? Can somebody tell me? What is t of n minus 1 value is going to be? Students, if t of n is equal to t of n minus 1 plus 1 means what will be t of n minus 1? In the first equation, instead of n, substitute n minus 1, you will get an equation. Yes, it is t of n minus 2 minus plus 1, because take the first equation as it is. Take the first equation as it is. Wherever n is there, substitute n minus 1. Left side, instead of n, you have substituted n minus 1. Right side also, instead of n, if you substitute n minus 1, it will become n minus 1 minus 1. It will become minus 2. So it will be t of n minus 2 plus 1 will be the value of t of n minus 1. Let me take it to be equation number 2. Let me take it to be equation number 2. And now coming after this, okay, coming after this, the next thing that I should be doing is, let me take the t of n minus 1 value and let me place it in the first equation. So in the first equation, let me go ahead with t of n is equal to t of instead of t of n minus 1, let me take t of n minus 2 plus 1. I'll take this value and I will place it instead of the t of n minus 1. Then plus another 1 is available in the first equation. Okay, see, for example, I will take the same first equation as it is. In the first equation, t of n minus 1 value I have got. I will take that value and I will substitute it instead of p of n minus 1. Now I got p of n minus 2 plus 1, it will become plus 2. This is going to be third equation. So how we got this equation is we took this equation number 2 and we substituted it in equation number 1. That's how we got this third equation. From third equation, what we need to do is on the right side, what is the term we have? We have t of n minus 2. What is the value of t of n minus 2? Use the same technique and tell me what is the process of t of n minus 2. What is t of n minus 2? What is t of n minus 2 value will be equal to? It will be t of n minus 3 plus 1, because you just simply take the first equation, place it as it is. Left side, what you have taken, instead of n, you have taken n minus 2. Right side also, instead of n, you take n minus 2. Here, right side, instead of n, I will just simply substitute n minus 2. How it will, what it will become? Minus 1, minus 2, it will become minus 3. So this will be t of n minus 2 is equal to t of n minus 3 plus 1. Let this equation be equal to equation number 4. And after this, I will take equation number 4 and I will just simply substitute it in equation number 3. Okay, I will just take equation number 4 and I will just implement this in equation number 3. Okay, so now what I will do is I will just have to take this equation number 4 and substitute in equation number 3. So equation number 3, if you just take t of n is equal to t of n minus 2 plus 2. So I will take fourth equation where I have the value of t of n minus 2, right? So let me take the t of n minus 2 value and let me substitute it in terms of t of n minus 2. So I'll just paste that instead of t of n minus 2, n minus 2. So I get this is going to be resultant t of n minus 3 plus 3 will be the equation. So let me consider this to be equation number 5. Is it everybody clear up to this? Now we are going to do a different process. Is it everything is clear up to this? Any clarification up to this, you can just please post in the chat box. Let me clarify it. Everybody is clear up to this, right? Yeah, fine. So now I will just go ahead with the next one. After this, I need to do generalizing the equation. Okay, we need to generalize the equation. Okay, generalize the equation. How will we generalize the equation? Which equation we need to generalize? We need to generalize equation number 1, equation number 3, which are in terms of P of n, right? And equation number 5. You take equation number 1, 3, 5, they have to be generalized. How we can generalize? I can write it as P of n is equal to T of n minus k, n minus k plus k. Why I write like this? N minus k, T of n minus k plus k. So T of n is equal to T of n minus 1. So initially it was minus 1. Third equation minus 2. Next equation minus 3. So that value is changing. Because it is changing, I'm generalizing. I kept it as minus k. But after you just look at here, first equation, if it is minus 1, this is plus 1. If this is minus 2, this is plus 2. This is minus 3, then it is plus 3. So if I take it as minus k, then I have to take the remaining part as plus k because both is always equal. That's how I generalize it. So this generalized equation, let me take it as 6. Is it everybody okay with the generalized equation? How we generalized it? We took equation number 1, equation number 3, equation number 5, and we looked the normal common pattern, and according to that, wherever minus 1 plus 1, minus 2 plus 2, minus 3 plus 3. So instead of that, we placed minus k plus k. So is that generalized equation is clear for everybody? Is the generalizing generalized equation is clear? Okay, fine. So now after this generalized equation, if you see after the sixth equation, after generalizing this equation, the next thing that I will be looking into is when this, like I just repeatedly going T of n minus 1, T of n minus 2, T of n minus 3, T of n minus 4, and it keeps on going. When we can stop it? When my parameter value becomes 0. And the parameter value becomes 0, I can stop. So when this n minus k becomes 0, I could stop. It will become T of 0, right? So when it will become T of 0, when n minus k is equal to 0, we can stop. When n minus k equal to 0 means what I can say? I can say n is equal to k. When n minus k is equal to 0 means if we take the minus k to the right side, it will become plus k. So we can say that n is equal to k. We can say that n is equal to k. And when this n is equal to k, what we could do is we can just take in that sixth equation, wherever k is coming, you take n instead of that, because n and k is equal, right? So I'll just take n T of n minus n I will take, because instead of k I will take n. So plus n. So let this equation be seventh equation and the final equation, where in this equation, if you look at what is n minus n will be, n minus n is 0. What is T of 0 will be when n is equal to 0, T of n is equal to 1. So T of 0 value will be equal to 1. T of 0 value will be equal to 1. So T of n is equal to 1 plus n. Okay, T of n is equal to 1 plus n. Okay, so 1 is a constant, right? Usually in the process, as we said, we will be removing the constant term. So we can take it to be T of n is equal to n. So n is the final equation. So you can say that this comes into the category of big O of n. Okay, big O. Always this will be giving you the maximum time. It will not give you the efficient or minimum time. Always this recurrence relation will be giving you the maximum time. So I am representing this as big O of n. That is a climax time complexity. So I'll just repeat what we have done already. T of n is equal to T of n minus 1 plus 1 is the original equation, first equation. Whatever is available on the right side, on the right side, if there is any t term is available, we will try to find the answer of it, T of n minus 1. If T of n is equal to T of n minus 1 plus 1, then T of n minus 1 is in the first equation. Instead of n, if you substitute n minus 1. Instead of n, I am substituting n minus 1. Here, instead of this n, if I substitute n minus 1, it will become n minus 1 minus 1, which will become n minus 2. Because already there is a minus 1 in the formula. If n also becomes n minus 1, it will be altogether, it will become n minus 2. Then plus 1. So this is second equation. Now, if I take second equation and if I substitute in first equation, so you take the first equation T of n equal to T of n minus 1 plus 1. So instead of T of n minus 1, you take T of n minus 2 plus 1 and substitute. You will be getting T of n minus 2 plus these 2, 1 will be added together and you will be getting 2 plus 2. And then from this equation, right side, you have T of n minus 2, right? We'll try to find the answer of that. Where in the same first equation, instead of n, if you substitute n minus 2, you will get this T of n minus 3 plus 1, which becomes fourth equation. Now you take this fourth equation, substitute in third equation. So T of n is equal to, instead of T of n minus 2, I'll get T of n minus 3 plus 1 plus 2, it will become plus 3. Now we took equation number 1, equation number 3, and equation number 5, and we generalized it as T of n equal to T of n minus k plus k. And we look at the base condition. If n becomes 0, we will stop, which means parameter. So if this parameter, t parameter becomes 0, so n minus k is a parameter. So if that n minus k becomes 0, we can stop. So n minus k equal to 0 means n will be equal to k. So wherever k is there, I substitute n. So when I substitute n, automatically it becomes n minus n 0. T of 0 answer is 1 plus k. Instead of k, we take n. So 1 plus n, 1 is a constant we remove. So remaining stuff is n. So we take this to be big O of n as a time complexity. So I have just repeated the entire stuff again. Is it everything is clear? Any clarification, post it in the chat box. Will take 2 to 3 minutes. Okay, for 3 minutes, let me observe your chat box and let me clarify your doubts. Okay, I'll not be speaking for 2 to 3 minutes, so don't think that I'm not audible. Okay, so everybody, let everybody post, because a lot of people are posting. Like your enormous count of people, so a lot of people are posting. So I need to just sit and I need to check and I need to read it. It will require certain time. So 2 to 3 minutes of time, just give me. Let me look into it. Any doubt, then I will check and I'll just tell you. See, we did not ignore n less than 0. See, we did not, ignore n less than 0. We started with n less than 0. T of n is equal to T of n minus 1 plus 1 is n less than 0, right? N greater than 0 case, right? So we are not ignoring n greater than 0. N less than 0 is not required, because n becomes 0 itself, we are stopping the process. N is not allowed to go less than 0. So if n is equal to 0 itself, we will be stopping the process. This program will not allow n to go below n. So that's why we are not considering that. That's first thing. How step 1 came? We formed a recurrence relation, right? I think I showed you how we have to form recurrence relation, right? So the entire function will be taking T of n unit of time. Then individual line, whatever time we have written, then we have took everything, we added T of n is equal to T of n minus 1 plus 3, right? Because of that first equation only, we got, because of this recurrence relation we formed only, we got this step 1. If the entire function takes T of n unit of time, n greater than 0, that line will be taking 1 unit of time. Printing will take 1 unit of time. If FUNC of n is taking T of n unit of time, then FUNC of n minus 1 will be taking T of n minus 1 unit of time. That's how that step 1 Okay. Can you please explain the generalizing part if n is equal to k? Okay, fine. I'll just explain that. Um, See, looking at the generalizing part, if you see wherever we have got this, okay, wherever we have got this, complete, T of an equation number one, equation number three, and equation number five we have got. So equation number one, if you take it is T of n is equal to T of n minus 1 plus 1. And similarly, T of the next equation that we have got is T of n is equal to T of n is equal to T of n minus 2 plus 2 is the next third equation. And the fifth equation is T of n is equal to, okay, T of n is equal to T of n minus 3 plus 3. So this is the next equation. So T of n is equal to T of n minus 1 plus 1, T of n is equal to T of n minus 2 plus 2, and then T of n is equal to T of n minus 3 plus 3. So these are the three different, functions that we have. So by looking at these three equations, one thing is very clear. If it is minus 1, it is plus 1 here. If it is minus 2, then here it is plus 2. Minus 3, if it is plus 3. And that is a changing terms also. Other terms are not changing. So we are write this as T of n is equal to T of n minus. We can take it some general term k. Some general element k we will take. So if it is T of n minus k, we can write this as T of n minus k plus k. This is minus k, then we can write it as plus k, we can write. Okay, so then this equation can be, this equation we are taking, and see here, if k is equal to 1, so T my n minus 1, n minus 2, n minus 3, n minus 4, keep on going. When this process will be ending, suppose if this n minus k, it has given 0 means you will give t of 0. T of 0 means that is the ending point. So the process will stop. Okay. So that's why what I did is I said that this parameter should become 0. So how this parameter will become 0? N minus k will be equal to 0. So when how this n minus k will be equal to 0? When n is equal to k. Okay. So if n is equal to k, then I can say that this n minus k will be equal to 0. One minute, students. Okay, so here n will be equal to k. So when n is equal to k, I said this parameter will become 0, right? So wherever k is available in this equation, you substitute n because both are equal. So this equation automatically become t of n is equal to t of n minus k, which is n minus n. Then plus, instead of this k, we will go with n. So plus n. Okay, so here n minus n will become 0, so it is equal to t of 0 plus n. Okay, t of 0 plus n. So t of 0 plus n, t of 0 means if n is equal to 0, they have said very clearly t of n will be equal to 1. So t of 0 means this value will be equal to 1. So 1 plus n we got. So constant term we ignored, so we got n. So t of n is equal to n. Can consider that t of n is equal to n. So this is the final equation we got. That's why we said it is going to be big O of n is the time complexity. Big O of n is going to be the time complexity. Okay. So now the next thing is I just wanted to, like put forth one more recurrence relation, and I will be asking you to solve it so that you could get clear idea of it. So I'll just give you one activation, one recurrence relation. T of n is equal to, go with t of n minus 1 plus n. This is the equation, and this is if n is greater than 0, and if n is equal to 0. Okay, if n is equal to 0, then definitely t of n will be equal to 1. So if n is greater than 0, if t of n is equal to t of n minus 1 plus 1, then t of n will be equal to 1 if n is equal to 0. Take this equation and solve this equation kindly. Student, is my voice clear now? Just, like for the given equation, you do the same process and please tell me the answer, please. Okay, a lot of people says it is going to be big O of n square. Okay, order of n square. There's a lot of people I see. Yes. Can you just, yeah? Can you just post me the last equation, the final equation that is in hand, the generalized equation? Can you just post me with the generalized equation in the chat, please? Okay, fine. Students, just everybody go and take your lunch and come back. After the lunch, we will again start by 2 o'clock, okay? And then we will just continue with all the different things. Right? So after lunch, we will be meeting again by 2 o'clock, okay? So everybody